The reason why determinants are important. The reason why determinants are important are because we get to use this thing called Cramer's rule.
I love it. Do you like it?
And Cramer's rule allows us to start solving systems of equations really, really fast. It's a great thing to be able to use. But first, we need another autograph.
Oh God, no.
Yes! It was in the paper. I just happened to find it.
Bad.
That's awesome.
What is that?
I need your autograph. You have to sign it.
What is that?
Wait, Kayla, if you run a marathon, wow, try hard.
What is that from? Please no.
You need an autograph.
Kayla, you ran a marathon?
Dun 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 dun. You have to sign it. Everybody else has always signed their
That
autographs.
is not going on the wall.
Yes, it is.
No.
Yes.
Like for like my senior year.
No.
When it's like,
Yeah, look at Kelly Raff. She's on. She's asleep.
I
remember that
wearing
picture. I was
She's
like,
even saying that is great.
Which we all know is a lie.
It's so bad. I'm not signing that, and you're not signing it on the wall. Not so bad. Oh, that's good.
What are you doing?
What? Nothing.
It's really not bad. I mean, you're-
She can sign over it. I can move it.
No.
I didn't say anything out loud.
Yeah, you did.
She does just like take her
I hate life.
No, you don't. Now you get to have your name on the wall.
Yeah, it's so bad,
That's
though.
signature though. That's sick though. That's sick.
Pretty.
Now it looks worse.
Wait, the K, like.
Layla. Oh.
There you go. Anyway, Cramer's rule. Here's what happens. I'm going to start with this. I'm not even going to bother showing you guys straightforward all their mumbo jumbo in the book. Shh, guys. And I want to start with a very simple 2x2, 2 equation, 2 variable system. Now, when we've done these in the past, we've all done linear combinations, substitutions, some eliminations, one of those types of methods to solve the systems. Those are still easier to use for 2 variable stuff than Cramer's rule is, at least I believe. But it's an easy way to introduce you guys to how it's used with the larger systems. For 3x3s and anything larger, it literally takes seconds to solve these now. So here's what happens. In this problem, what I want to do is create what's called a coefficient matrix. And if I'm going to create a coefficient matrix, what do you think I'm going to be using? Coefficients. Now, in this problem here, how many coefficients do you see? 4, right? Because my answers are 1 and negative 23. So here's what I'm going to do. I'm going to create what's called a coefficient matrix. And I'm going to take its determinant. I take the determinant of the coefficients. I do that first. Now, 2x2 matrices are really easy to work with as far as determinants are concerned. And you probably recognize that over the homeworks. Quick multiply and subtract. In this case here, when I find my determinant, I get negative 4 minus 3. Is everybody okay with me just writing it like that? What do you get? Good. So I get negative 7 for that original coefficient determinant. Now, in order to solve for x and solve for y, here's what we do. Do you guys agree that this right here creates a column matrix?
Yes.
Okay. That column matrix is the answers. Equals 1 equals negative 23. Here's what we do. I take the answers and I put that column in for the variable that I'm solving for. This was my x column and my y column. So if I'm going to solve for x, I take my solutions, 1, negative 23, and I put it into the x column. I keep the identical y column there. And I find that determinant. I'm going to walk through this a couple of times. What I'm doing here again is I'm taking my solution column, 1 and negative 23. And I'm substituting that column into the x column here, maintaining the same y column. Oops. All right. Find the determinant again. I get negative 2 minus a negative 23, which equals 21. Now here comes the tricky part. Once I find that determinant, I divide it by the original coefficient determinant. Divide it by negative 7. X is negative 3. Yeah.
Is that to be in that form, the original equation? It can't be like y-intercept form?
You could, yeah, you have to put it in standard form. You got to put it in standard form. I don't think you're going to see them not written in standard form for these ones. They generally just put them out like that. I do the exact same thing for y. In order to solve for y, I put that answer column in for the y's, and I put the original x column back in, 2 and 3. And I do the exact same thing. I find its determinant. 2 times negative 43 gives me negative 46, and I subtract 3 times 1. And then what do I divide that by? Negative 7 again. So y is 7. So this becomes a real quick, efficient way to solve systems and equations by using nothing more than determinants. And solving 2 by 2 determinants are really easy. Okay? Not bad.
Not that bad.
Let's try another one.
But I still, when just using substitution be easier?
Yeah, when you're using substitution elimination methods for 2 by 2s, yes, it usually is easier. But what I'm doing here is showing
the 3 by 3s.
and you see how much quicker it is if you were doing this by
I think
finding
it
much.
would be easier.
It is. Plus, I'll let you use your calculator for 3 by 3.
Oh.
Carry.
What's that? I became more of a fan of Seinfeld after it was on. It's a lot funnier now.
Yeah.
Where's
It
the
was.
Seinfeld? Do you have a Seinfeld poster? Or like what? When he asked you, you like looked over there.
Because he's sitting over there.
No, you
Yeah,
like looked at the
yeah.
fridge. You looked at the fridge snowman as if that was.
Is Seinfeld like a noun or what? What is Seinfeld?
Seinfeld is a noun because it's his last name.
Is his first name Jerry?
Oh, so it's not.
Could
yeah,
be.
it's a thing.
You don't know?
Possibly.
Or-
It's nobody knows. This is just kept it secret all this time.
You don't know who Seinfeld's first name
Is his friend's
is?
name?
Isn't it Jerry?
Yes.
Or why don't you say Cookie?
Something sarcastic.
I think you are.
Are you sure?
At least.
All right, let's try another one. What about this?
I like that.
Once again, I'm starting with the following equation. 8x plus 5y is 2. 2x minus 4y is negative 10. From that, I always want to find the determinant of the coefficient matrix. My coefficient matrix is going to look like this. I have an 8, 2 for the x column, 5, negative 4 for the y column. Negative 32 minus 10 gives me negative 42.
Alright.
Just, what's that? Now to solve for x, I put my answer column in the x column. So I have 2 and negative 10, and then 5 and negative 4. Find that determinant. What do I have to divide that by then at the end? I have to divide that by negative 42. So you have negative 8 minus negative 50. So it becomes what? 42. And 42 divided by negative 42 is? Negative 1. Now, I know someone's going to ask, can I just substitute in and solve for y now? You could.
Can't do that. It's the last.
Yeah, but here's the deal. I'm going to have you guys do 2 by 2 Kramer's rule by hand. So I want you to show the work for the Kramer's rule stuff. Okay. That also reminds me, when we do the test in this chapter, it's starting to look more and more that it'll be next week. The test will be on Tuesday, but I want to do calculator, non-calculator. And I'm thinking that on Monday, like the last 20 minutes of class or so, I'll give you guys probably 4 problems of non-calculator stuff, whether it be Kramer's rule, well, definitely be a Kramer's rule, maybe an area of a triangle problem, a multiply problem, something like that. Tomorrow we're going to talk about what are called inverses. I had to do one of those by hand as well. Those shouldn't take more than 20 minutes. That way we can focus all of your attention on the calculator portion on Tuesday. Yeah.
Is Kramer's rule like national or like just a school?
No, it's a national. It's a worldwide phenomenon.
Like who's Kramer?
I don't know. Some guy. Yeah, I have no idea.
Dan Kramer?
Could have been Steve. I don't know.
Could it have been from
And I do the same thing for the y's now. I go back to the original column for x. Oops, I need to move this up. It was 8 and 5, right? 8 and 2. Thank you. The answer column is 2 and negative 10. This class doesn't go by that slow. You're whining.
I think it's just algebra, like in general, just subject.
Negative 84, good.
Are you gonna make these all non-decimal?
Is that the worst ones you get when you do these things by hand, you'll get normal fractions because it's halvesies. You just simplify fractions. Okay? All right, so let's get into the fun stuff then. Let's get to the 3 by 3. What do you think, Chick? You know what? Let me give you one on your own.
Please, no, please.
Do this one.
Please.
Take a minute and do the 2 of us. Are you guys well? Do you have any issues so far? You gotta watch. Careful with those. Negative 3, negative 23, 7, and negative 8. When you get that determinant, it was 161 minus something, right? I think the answer becomes negative 5, right?
Yeah.
Okay. I remember doing this earlier, so I think it's negative 5 because you divide it by the negative 37. And then the y value, 2, 3.
Wait, did you get 5 or negative 5?
Was it negative 5 or positive 5?
I got
Negative.
Negative, right? Okay. And then the other one was positive 1, correct?
yeah.
Everybody got 1? Yeah.
For X, I got 5 because plus or minus subtraction, right?
So it's 24
Yeah, I can't hear
plus the 161. So yeah, you get positive 185 divided by negative 37. That's where you get negative 3. That's why. And that's where you're going to make your mistake. You'll forget where it was. All right, let's look at 3 by 3s.
Yeah.
Enough, please. 3 by 3s. We do the same idea when we're working with 3 by 3s, but now I'm going to let you guys use the calculators because it makes life a lot easier. There's no reason for us to start cranking out 3 by 3 determinants by hand because you have to find 4 of them and then you got to divide stuff out. Yeah. That's mine.
You can't have it because it's I forgot mine in my locker. First time in my life.
Well, you know, at least you did lose yours.
Yes. Wait, sorry.
Anyway. Now in this case here, we are still going to find the determinant of the coefficient matrix. The coefficient matrix here is going to look like this. We have 1, 1, 3, 2, negative 1, and 4. I'm going to find that determinant. Remember, solid upright stand for determinant. Let's use Sarah's shortcut that she helped us with last week.
Sarah.
Oh,
What do you
She gave us the.
No, I knew there was.
I see what
All right. Remember the easy way to get to the determinant, because you have to find that. Second matrix.
Oh yeah, I used.
Go to the right one and hit enter. You'll get DET. Now we have to figure out what we're finding the determinant of. Well,
What was that?
Like,
That was so fast. That was like.
second matrix.
Go to the right and then hit 0.
Go to the right and hit enter.
Go to the right and hit 0.
Wait, I missed it.
He's like 2.
Wait, hit.
Forget that.
Second matrix. Go to the right and hit enter.
Wait, Mr.
You get
Murphy.
DET.
Mr. Murphy.
There is. Yeah.
What does the 0 mean? I just like completely lost it. Like,
When you go second matrix,
like there's T, dim, P, identity, random.
There's a lot of programming things you can do with matrices, but we're not worrying about it in this class.
Materialist,
All right.
listimator.
So now I want to create the matrix. Alpha zoom. Alpha zoom will allow us to create 3x3, 2x2, whatever it may be. But you just have to look at it and figure out how many rows and columns. In this case, we're making a 3x3.
Okay.
Click OK.
okay.
Fill in the blanks.
Wait, where's the problem? Oh,
We're over here. 1,
my bad.
2.
Yeah, that's it.
Oops. Nuts. I didn't enter. I didn't go
Yeah,
into
that
it.
completely wrong.
All right, I screwed up. Sorry. Don't hit enter. That's why I messed up.
Yeah, I did that too.
All right, just hit to the
Doesn't
right.
matter.
Should we hit enter or something?
Not until you get everything entered in there.
It's
Why
on.
do you need the two?
I forgot.
Go to the
I
right.
hit-
So we don't need.
I accidentally pressed enter instead of pressing to the right. I have to fill in my matrix. I have not filled in my matrix yet. So I have to go 2, -3.
Why does it say 2D?
I don't know. I will get rid of that.
Oh, okay.
I wish I knew how to get rid of mine.
I don't know.
Go all the way over to the left and hit delete, and that one will go away.
Where's that? Oh, down.
I just got the back out of it. That's all.
I dare you to hit delete the 2. Del. Yeah, why?
-7. Remember, my calculator on the computer is unbelievably slow compared to yours.
Yeah, dude.
Okay?
Is
So
it
now,
plus megapixels?
what you have now is the determinant of the original.
Alright.
That's what you have to divide all the other determinants by. So when you go to solve for x, where do you put the answer column? Where do you solve for y, where do you put the answer column? And then where do you put the answer column when you're solving for z? What happens then is that you get the same idea. X is going to be the determinant of the, well now we have -2, 1, 4. And remember, this is a lot easier than having to crank these out by hand. Yeah,
Now, can you just keep doing this on your calculator?
for 3x3s.
Right.
Uh-huh.
So you don't have to keep writing it down.
No.
Okay.
Oh, and then to solve.
So what I did here is I wrote out what the value of x is going to equal. I know it's going to be that matrix, or that determinant, divided by the original determinant, that -7. When I go to find what y is going to be, my answer column now goes in for y's, so it's going to be 1, 1, 3 down the x. My y values are -2, -1, and 4. The z column is the same. And divide that all by the original determinant again. The thing that's going to happen when you type these in is you're just going to hit the wrong button. What's wrong? You're typing something incorrectly.
Well, just real
Shouldn't be. -2, -1, 4.
Or what?
Yeah, I got 0.
Okay, wait, what is X? I got 0.
Yeah, 0 for x is right. Because the determinant was 0, divided by -7, you get 0. That's true. 3. Oh, here's why. You put -2 for that top right, it's supposed to be -3. And then you have -1 here, it's supposed to be 4. Or are you doing the,
Oh, that's.
for z? Then you have to have a -2 here for x. See how easy it is? And it's not that you're doing the math, not that you're doing the process incorrectly, but you have to be very careful when you're typing it in. Okay? Watch those signs, guys. Watch when you're typing it in. That's what you're going to mess up.
But still, you get something weird though.
You shouldn't. Should work out nice and clean.
It doesn't.
Did everybody get 0 for x?
I'm so far behind.
Are you just
No, I just don't even know how to enter it in.
second matrix?
Is Y 5?
I don't remember off the top of my head.
Well,
Go to the right
no, I
now.
have right
That's how you find determinant. Now, you have to get a alpha zoom.
Okay, that's right. And then I got here.
Now scroll down to where it says okay. Now your original, you're trying to put the original now. Hit 1, right one.
Okay, yeah.
Gotcha.
I think I was saying right.
Why is
It
I got
didn't
you.
say
Did
determinant.
you guys get 5?
I got 5.
How do you get that? I don't know.
Negative on the 4. Negative on the 4. It's very easy to mess up a value by missing a sign. Remember, hit second enter and you can go back and overwrite the information. Okay? Second enter will allow you to go back up to overwrite.
So x is equal to 0, y is equal to 1, and z is equal to 0.
I think y is 5.
Yeah, I got 5 for Y.
So the y value, let's see here, we have 113, -2, -1 to get in here. I'll change mine up.
No, but I thought the answers were the same.
Yeah, and
as-
then Z is 4.
You put the answers into the y column now?
Yeah, but it's the same thing as if they wanted to know.
No, they're not. Because it's
they are
-2. The original is +2. Watch the signs.
It's wonderful.
Why does he say why?
Yeah, I was thinking that.
Then you have -35 divided by -7 is +5. See how you can just mess up one thing and it looks like it's right, but it's wrong. Okay?
Yeah, you're doing it.
And then z,
Are we allowed to use this
the 2 by 2, the stuff you're doing last night you should be able to do by hand. That should have been all easy by hand. Okay. And then when you go in for z, you put that answer column in there, you get the -2, -1, and then +4. This column
Because you could go
becomes
to like the right
two.
of it and click enter. You don't have to go like all the way back.
That should be okay now. And then I divide -28 by -7, I get 4. Did you guys get 4?
Yep.
Okay. Like I said, when you're getting into these problems with the determinants and Cramer's rule, the biggest mistake you're going to make is that you miss a sign, you forget which column you're in, or something stupid. All right? That's all it is. As long as you remember, answer column goes into the column of the variable you are solving for. The other 2 columns stay the same. And you always divide by the determinant of the original problem. Okay? Let me give you one of these to try. Or you know what? Let's just call it a day. All right, so this is same page, 219. Here's what I want you to do. 40 and 42 by hand.
Is this the homework question?
help you set up number 60.
Oh, dear, please.
What does Adidas stand for? I heard it stands for all day I dream about sports.
Oh, change.
I have no idea. I've heard many different
Is
things.
that a Venus? That was
That was just a word. I wrote this number 60.
No. What was the other number?
Hey, look at number 60.
No.
It's talking about atomic weights. Last time I checked, atomic weight was the weight of an atom. Whatever. And when they're talking about subscripts with elements, that means how many sulfur does it have? How many nitrogen does it have? S sub 4, N 4. F is fluoride, right? Fluorine, whatever. I went into math. So if I'm talking about a problem like this, and I'm trying to figure out what the atomic weight of each of these individual elements are, do you agree that we're going to wind up with, do you guys all see 3 different variables there?
S, N, and F.
Okay. Some of them use all 3 variables, some, or in this case, only 2 variables are used in each one of those 3 equations, correct? So what we wind up with is 4 S's, 4 N's, and that has to equal how much?
181.
Okay. Now we have 1 S,
6F.
6 F, and that has to equal how many?
1.6.
And then no S, 2 N. What is my original coefficient matrix going to look like?
Is it going to be 4, 1, 0? Or do you not do
I'm going S and F. So
What are you trying to find?
I'm going to find the atomic weight of each variable, of each
Oh,
one.
4, 4, 0?
Why is it 0 and not 1?
Because there's nothing there.
Because there's nothing there. What happens here is that this is a 0F. This is a 0N. This is a 0S.
Does that result in the same answer? Or 0 F?
Yeah, because 1 would tell you that you had something there. So what you're doing is you put it in zeros for your placeholder. So when you create your matrix then,
But then it's 0, isn't it, when you're multiplying them all up?
are you going to do this by hand though?
Well,
I calculated.
just thinking about it.
It's not going to be 0.
Won't they all have a 0 on the thing?
No. Oh,
Which
because
one
the top will be.
Oh, the 1, 4, and 4, and the 2, 6.
You'll figure it out as you go through it.
I see.
It'll be like
Okay.
negative though, right?
Oh.
It'll be negative.
If you tell me that it's negative, will it be?
It'll be negative.
No, I can have a problem.
It's 0 minus
Go ahead and get walking through these things.
12 times.
What we do tomorrow, oh, excuse me, let me go back here so you can write down. What we do tomorrow then is we introduce you guys into another, instead of just doing determinants, we're going to find what are called inverses. And inverses will allow us to solve some of those matrix equations even easier. And there is a button, don't worry. It means if it's a 2 by 2, you can do it by hand. If it's anything larger than a 2 by 2, we can use calculators. Okay? We can do 6 by 6 if these things. Well, in this case here, if you have to do a 6 by 6, you'll have to do 7 determinants. Your calculator does it for you. Okay? Only 7, I know. It's up to